Hi, dear students, Dr. Shiva here. How are you? Hope all of you are doing in a good health. And as you all know, according to our USM top management, the official teaching, they have requests and asked all the lecturers to deliver their teaching and communicate with all the students through online media or any other alternative media. Therefore, I've decided to use video recording for all my lectures and Zoom for discussions or Q&A sessions. As you all know, I have uploaded all my notes and tutorial in e-learning for the vector notes, and tutorial also I have uploaded. And basically, time to time I will try to give you simple quizzes to verify your understanding for the verification of these online teachings taking place effectively. In order to access to my course, my enrollment key is EUM1148. You are required to enroll into my course, Dr. Shiva Kumar, in e-learning, and the enrollment key is EUM114A. Please refer to our main page, EUM114 Advanced Engineering Calculus in e-learning, and you will get it all this information from there. As you all know, you may have difficulties to join in online sessions. Therefore, I decided to record all the lectures through this video recording, and the reason is very simple. And basically, as you all know, there are 600 students, and it's impossible for us to have one big sessions for long sessions for this topic. Therefore, I've decided to record all my video, my lectures using this video recording. But no worries, time to time we can discuss through e-learning forum as well, or I'll try to communicate with you through Zoom discussions as well. To be realistic, it's impossible to answer all of your doubts through forums or what you call e-learning, but I'll try my best to communicate with you through any online media as possible. And please use relevant YouTube, which is related to the vector topic that I'm going to discuss with you for your further understanding. That may help you to enhance your understanding in this vector. To be realistic, as I say, I may suggest some of the YouTube for you, which might help you very much in the for your clarity, to get a good clarity in this topic. Okay. As you all know, vector is one of the important topic in EUM114 Advanced Engineering Calculus, and the topic basically is quite different from what you have learned so far. You have done Fourier series, you have done partial differential equation. Now we're going to learn vector, and after that you're going to learn matrix. Okay, vector is one of the very challenging topic, and in order to understand this topic, you are required what I may say is a good visual understanding. Okay, to solve the vector problem, you are required to have a very good visual understanding. Okay, let me without taking much time, because I'm recording all my discussions. Therefore, what are the topics that will be covered in the vector? Okay, first I will cover with you what is vector. Okay, what is vector? Okay, I'll try to define to you what is vector. The next will be, I will cover with you unit vector. Unit vector. Number 3, unit tangent vector. Unit tangent vector. Number 4, I will cover with you unit normal vector. Okay, number 5, I will cover gradient. 6, directional derivative. Divergence. 8, curl. 9, okay, number 9, line integral. Okay, line integral. Number 10, surface integral. And divergence theorem, or we may call it that as a Gauss theorem. 12, Stokes theorem. Okay, with this topic, okay, these are the coverage of these 5-week lectures for the vector topic. What is vector? Unit tangent vector, unit normal vector, gradient, directional derivative, divergence, curl, line integral, surface integral, divergence theorem, which is Gauss theorem. We may call it that as a Gauss theorem, Stokes theorem. Therefore, there are altogether 12 sub topics, I may call it, which I'll cover in this 5 weeks lesson. I hope that all of you take a one paper and just follow whatever that I'm writing here. As you all know, mathematics required some writing. Okay, you need to take a pen and pencil or anything, just follow mathematics by just write. Okay, when you start doing that, it's possible for you to follow the lectures easily. Okay, since this is a recording version, you can repeat this video several times for your further clarity. Is because, as you all know, vector sometimes required a lot of although every piece of information that I'm going to share with you is it's contain a lot of information. Not only information, it's required a lot of visual understanding. Therefore, please try to follow the video carefully, and if you have any doubts, as I recommended, you can follow some other YouTube, which is some other lecturers YouTube video, or any website which I have suggested in my e-learning also. You can refer to some online topics related to the vector to get a better understanding. Okay, now simple question: why are we learning vector? What is the reason behind we need to learn vector? Is there any particular reason why we should learn vector? Okay, vector. Basically, vector is one of the very interesting topic. In simple, vector will give you what I may call it as dimensional thinking. Vector is a dimensional thinking. When you start when you start seeing things, basically you are trying to understand the dimension of any object or any visual objects. Therefore, vector will provide or may give you a dimensional thinking. That means it will provide to see the dimension of any object in a different what we may say is in a different context. Okay, what I mean by dimensional thinking here. First of all, let me introduce to you one simple logics here. Okay, when we started seeing any particular object, how do we perceiving, or how do we see these objects? How do we see this object? When we see this object, we try to measure the objects. When we use a measurement is a way to understand any objects. People, when we start measure this object, there are several ways to measure the objects, or we may use several dimensions to measure the object. Maybe we may measure the weight, maybe we measure the length or height of this object, or the form of this object. Okay, therefore all these measurements will reflect or may give you the detail of what we call as the magnitude. Okay, it will provide you the detail or the magnitude of that object. Okay, when we say this magnitude of this object, it's the magnitude basically is a refer to this object, the contents of this object. Okay, the detail of this object will be referring to the object itself, or whatever that the detail or the information is about this object. It never go outside of the detail outside of this object. What I mean by the outside here, we won't be able to get information like the location of this object. Where is this object is located? The magnitude will just inform you the detail of this particular object. Therefore, we call it this as a scalar. Okay, scalar, or we may call it this as a scaling. Okay, for example, we may say how much to weigh this when I weigh this object. Okay, how long? Okay, now therefore, in simple, we may say I'm measuring the physical quantity of a particular object. This will give me the quantity, okay, physical explanation about this object. The good example for this is a temperature, for example. Temperature, pressure, weight and etc. Okay, when we use a scalar, what are we measuring? As I say, okay, we are measuring the magnitude. Of course, you may ask, okay, I can understand magnitude is something about this object, and this will give us, the scalar will give us only one piece of information. Okay, this information, okay, one piece of information, which is magnitude. Okay, magnitude. Magnitude only. Therefore, in vector, they call it this as a zero basis. Zero basis. Why it's a zero basis? It only able to be able to see at a particular point only. Sorry. Okay. Now, this one piece of information is not enough to understand any particular object. Therefore, is there any detail that we can further detail that we can explore when we explore any particular object? What I mean by explore here is when we wanted to detail out the detail of any particular object. Therefore, as I mentioned on the top, this is a dimensional thinking. Is there any possibility for us to get further detail about this object? Therefore, in 1980, AD 1636, Descartes and Fermat Descartes and Fermat introduce a method, a method to see the object in a different perspective. Different perspective. Okay. This we call it as a coordinate system, which is we call it that as a Cartesian coordinate system. Cartesian coordinate system, whereby we can analyze any dimension of the object in the space, in the space, where is the object. That means we are able to locate the object in a particular locations. Is there any possibility for us to locate any objects in a particular location? From location of object. Therefore, the contribution of the Descartes and Fermat, they have given us to see any phenomena in a different perspective. What I mean by different perspective means, from the scalar perspective, we are able to see any particular object and their location, we are able to identify through what we called as a Cartesian coordinate system. Cartesian coordinate system. With this too, now we started looking at the object, not only the object itself, the scalar detail or the scaling, the magnitude of particular object. We are now able to see some detail about the location of that particular object. But later, people, especially the scientists, started explore further detail about this Descartes and Fermat phenomena. They really wanted to know not only the location of this particular object. Is it possible for me to identify the direction of these objects? Basically, Descartes and Fermat already contributed for the understanding of the directions, but it's not detailed. But this is not in detail, and because of the Cartesian coordinate system only able to give you the location of a particular objects when we refer to the original point. Therefore, the mathematician introduced vector as a solution to get a further detail about any object. This vector will able to give us the detail of magnitude of particular object and the direction of that object. This is a one biggest breakthrough, whereby we are able to see not only the detail of we not only able to acquire a detail of a particular object, but we also able to see the direction or the movement of that object. That is the one of the very important breakthrough in this, when we started seeing the dimensions from the scalar to the, or we transform, or we move from the scalar dimensional view to the vector dimensional view. Vector dimensional view able to give us not only magnitude, not only it able to give you magnitude, it able to combine components in three components of Descartes and Fermat in magnitude, space, and plus it able to give us direction, direction, which is it able to, we say that as a one basis. What I mean by one basis here is it will give you a one more informations which is the base for a particular object. It will able to give you, provide you another informations about the object. Therefore, now we have two pieces of information. Two pieces of information. These two pieces of information can change in many ways. That means, what I mean by change, it may give us a different perspective from the scalar view. Let us explore in detail what is these two pieces of information can do to us. One of the best thing that I may able to say, so one of the things when we measure the detail, this vector become independent of units. You no need to see the detail of the unit of any particular object. any particular object length. Therefore, vector is independent of units. We no need to know the scalar detail of that particular object. We just need to know, okay, two information. One, we just combine this three magnitudes, the detail of the scalar, into three components in the space, okay, and it will add one more component called direction. Okay, because of this, we now able to see the object in any coordinate system x, z, y, and be able to see the direction of a particular object. Okay, we are able to address this object using some technique called direction. We can every piece of the information about this object and its direction can be addressed through vector. Okay, one of the good example, what is the usage of this? When we learn this, one of the very good examples for this what you call vector, we can use complex number. We can able to explain complex number easily through vector. For example, AIB. Okay, I means it's a complex number, which is I, here I referring to -1. Okay, the complex number can be written here as AB. Almost all the progress of the direction of any object will be addressed as V vector. Okay, on the top we will put one arrow on that. Therefore, the magnitude of the particular object can be explained as will be addressed as this. Okay, you can see here modulus. I use a modulus to address the magnitude of object, and the modulus will be written as Vy2 and Vz2. Okay, now is this how to add vector can be added. For example, in this particular case, I may say I may write here x1 y I plus with the x1 x2 I y2. This can be added according to the directions. Basically, it's not a directions here. See, it's basically able to segregate two different information clearly. Okay, this is one of the benefit that you can see very clearly here. Okay, you see, I can add this to the similar information I y1 plus y2. This is one of the benefit that we can explain the complex number in vector as well, but complex number actually is not referring to exactly vector. Complex number by itself is a one system or number system which we will study in a different dimension. But anyway, we can represent complex number in a vector as well. Okay, therefore vector can be explained in the three different field called physics. Okay, in the physics, math computer science. Computer science. Basically, in the physics, the vector will be explained as something called actual space, referring to the actual space and time. Okay. Now, in a mathematic, we will refer vector as V arrow on the top, and in a computer science, they will learn the vector using matrix. This is a matrix reference, but you must remember matrix here, this is referring to the I to J, as we can see. Matrix is not vector. Matrix is a different from the vector. But why matrix is not a vector in the first place? It never carry any basis. It never carry any information called direction. Okay, it never carry any basis for it won't be able to detail out the basis of any informations. Therefore, matrix is not a vector. Basis here is, as I say, is a kind of information on hidden information, the hidden insight. Insight means it's implicitly it will carry some information. The basis means it will be able to hide some information and it is able to carry this information implicitly. Therefore, but vector can be matrix, can be a matrix. It can use the matrix, the properties of the matrix. Therefore, one of the advantage of vector is it able to use matrix as is one of the property. Therefore, in physics, we learn vector as an actual space and a time. In mathematics, we will see that as two pieces of information, and in a computer science, we combine a matrix into vector for its applications. And the good example for vector is force, velocity. Vector space basically is a displacement of the object in the plane. The vector space here, which sometime will be represented in the matrix form, it's basically we are trying to see the movement of the object or displacement of the object in the plane. As I say, if we not only able to see the detail of a particular object, but we able to see the displacement of the object. Okay, we have done scalar. I have explained to you the vector, and one more important information that which might be a very useful to you is the usage of the vector is a field extension. Field extensions. What I mean by field extensions? Field extension is be able to identify a particular particles. Okay, we can able to monitor the progress of the particle as a field. Okay, that means we able to identify the progress of any the movement of any particles or any object in the space, we call it as a field. Here, this vector able to enable us to see the space, okay, in the space, the movement of the object. Therefore, it's a very clear, because of its direction, it able to give us the detail of any movement of this object. Therefore, very interesting here. The vector is one of the very powerful tool for us to see the movement of the object. Okay, now on the top of that, we also I encourage all the students to learn tensor as well. Okay, although the tensor is not in the coverage of this syllabus, but I wish all of you to learn the tensor as well, because tensor is one of the very powerful component for the very useful for the mechanical students. Okay, what the tensor can able to give us? Tensor basically able to give us three pieces of information. Okay, it able to give us not only magnitude, not only direction, it able to give us one more information called transformation. Okay, therefore this information, this basis, we call it this hidden information. Magnitude is a very obvious, which we can able to see. Direction and transformations are, we call it that as a basis. Okay, this is basis, this is a scalar, you can see. Therefore, on the top of vector component, tensor able to provide you one more information called transformation. Therefore, Einstein able to manage to produce what we call as a general relativity theory using tensor. Okay, therefore we able to see the dimension of any space in three pieces of information. What is the contribution of this transformation? Okay, you able to see the movement of the object. Not only you able to see the movement of the object, but you able to capture, the tensor able to capture what we call the interaction of the object with the other objects, or it may interact with the other surroundings. Okay, therefore it can inform us how the object interact with another I may call it that as a species. Okay, therefore tensor able to give us one more information, call it how the objects are interacting with the other species or other elements, maybe with the other elements. Okay, other elements. This is one of the very interesting two basis vector, as I say, two basis vector. They able to give us a direction and transformation. Okay, transformation. Therefore you can see when the we get this hidden information, call it transformation and direction. We able to see, for example, this object. Okay, this object. When something stressed, let's say we press this object to become compressed object. Let's say we make it a compressed bit. Okay, we make it as kind of compression. When we give a stressed, okay, we push this to make it a stress bit. Okay, when once we giving a pressure here to stress, okay, then it will transform this object into this form. Okay, we call it this as a transformation. This two basis object, there are, when we use stresses, see, okay, this is the first experience. I'm using a video recording, therefore a bit